Hello, everybody, and welcome to April's edition of IMPLAN's Lincoln Learn, examining the IMPLAN energy industries, a look at renewables. It seems that we still got a few people trickling on in here, so we're going to give it a few more minutes before we kick off.
Michael?
Hello, Angela. We're just giving it a few more minutes to let people trickle on in, and we can start whenever you're ready to go.
Okay. And remind me again, do I need to do anything on my end, or do
Yes,
you have to start it?
No, we've already started.
I'm not seeing the presentation.
Ooh, I guess I should show my screen. That's probably why.
Yeah.
I didn't mean to change presenter. So give you keyboard and mouse, show my screen, and here we go.
Okay, so the broadcast has started.
It sure has.
All right. Hello, everyone, and welcome to today's webinar. It is 2 minutes after the hour here. This is the April edition of IMPLAN's Lincoln Learn, examining the IMPLAN energy industries. Lincoln Learn is a monthly webinar series that gives users a chance to take a deeper look into various concepts with the Education Services team. In this session, we're going to take you through IMPLAN's energy sources and highlighting the key differences between energy generation versus transmission industries, then demonstrate how to utilize renewable energy industries when estimating economic impacts, and then finish off with a live example. But first off, I would like to introduce myself. My name is Angela Slavichuk. I am the Education Services Manager here at IMPLAN. Joining me today and co-presenting is another member of the Education Services team, my colleague, Michael Neely. Michael Neely is our Education Support Specialist who's going to walk us through a renewable energy use case example in the latter half of the webinar. Here at IMPLAN, we like to keep our Lincoln Learn series interactive by allowing attendees to pose questions throughout our presentation. However, today's presentation will likely take the full 60 minutes, so we ask that if you do have a question related to today's topic, please utilize the question box in the GoToWebinar. The Education Services team will do our best to monitor the question box throughout the presentation. If you think you might want to ask a question, just make sure that you have your control panel open by hitting that orange arrow on the upper left portion of the pop-up window. At the conclusion of the presentation, if we do not get to answer your question within the time frame, we will personally follow up with everybody to provide a response. As previously stated, we have a lot of content to cover today in this webinar, so we're going to start our presentation by giving an overview of the renewable energy in IMPLAN's energy industries and data trends. Then we're going to talk about how IMPLAN distinguishes between the energy generation and distribution industries. And then, of course, finish off with how you can use IMPLAN for an analysis to inform decisions on energy-related projects. So why discuss renewable energy? Well, to be quite honest, the topic is everywhere. With energy prices rising at the fastest rates in over 10 years, it is important as ever to be informed on how energy industries can and will impact regional economies. So what is renewable energy? Our definition comes from the U.S. Energy Information Administration, or the EIA, which is part of the U.S. Department of Energy. The agency is also responsible for collecting, analyzing, and disseminating energy information to promote public understanding of energy and its interaction with the economy and the environment. According to the EIA, renewable energy is energy from sources that are naturally replenishing but flow limited. Renewable sources are virtually inexhaustible in duration but limited in the amount of energy that is available per unit of time. There are 5 major types of renewable energy sources: geothermal, solar, hydropower, wind, and biomass. Renewable sources and non-renewable energy sources alike can be used as primary energy sources to produce useful energy such as heat, or they can be used to produce secondary energy sources such as electricity and hydrogen. Let's talk briefly about each one of the different sources of renewable energy to help us better understand how these industries work. The first one that you see here is going to be solar photovoltaic devices, or solar cells. These change sunlight directly into electricity. Arrangements of many solar cells in PV panels and arrangements of multiple panels in arrays are often referred to as farms. Some PV power plants have large arrays that cover many acres to produce electricity for thousands of homes. The one that you're seeing here is from Lancaster Solar Farm in southern Georgia. Next, we have hydropower. So hydroelectric plants use surface water flow to generate electricity. Because the source of hydroelectric power is water, these plants are usually located on or near a water source. At hydropower plants, water flows through a pipe, then pushes against and turns blades in a turbine to spin a generator to produce electricity. The volume of water and flow the volume of water flow and the change in elevation or fall from one point to another determines the amount of available energy in the moving water. In general, the greater the water flow and the higher the fall, the more electricity a hydropower plant can produce. The one shown here is from Fox River Hydropower in, I believe, Shawano, Wisconsin. Next up is going to be geothermal energy. Geothermal plants use hydrothermal resources that have both water and heat. Geothermal power plants require high temperature hydrothermal resources that come from either dry steam wells or from hot water wells. People use these resources by drilling wells into the earth and then piping steam or hot water to the surface. The hot water or steam powers a turbine that generates electricity. Some geothermal wells are as much as 2 miles deep. There are 3 basic types of geothermal power plants. There's a dry steam plant, which just uses the steam directly from the ground. Flash steam plants, which take that high pressure water from deep inside, convert it to steam to drive turbines. And then there's binary cycle, which transfers the heat from that resource in the ground to another liquid. That heat causes the second liquid to steam, which then generates the turbine. The one that's shown here is from the Geyser geothermal plant in California, and that uses steam. The fourth one is going to be biomass. Biomass is a renewable organic material that comes from plants and animals. Prior to fossil fuels, biomass was the largest source of total US annual consumption until the mid-1800s. Biomass continues to be an important fuel in many countries, especially for cooking and heating. The use of biomass fuels for transportation and electricity generation is increasing in many developed countries. In 2020, biomass provided about 5% of the total primary energy use in the US. Biomass sources include wood, agricultural crops and waste, biogenic materials in municipal solid waste, animal manure, and human sewage. Biomass is converted to energy through various processes, including direct combustion, which is the burning of it to produce heat, thermochemical conversion to produce solid, gas, or liquid fuels, chemical conversion to produce liquid fuels, or biological conversion to produce liquid and gas. The plant shown here is in California, Shasta, California. Oh, looks like we lost the webinar here. Apologies. You can just advance it a couple more times. Michael, seems like I've lost control of the webinar here.
Okay, I'm sorry about that, Angela. Let's see if I can't figure this out. Try it again now. Still nothing?
Nope.
Okay.
Oh. And just need you to advance it one more. Michael, did we lose you?
I'm here. I'm trying to figure out how to give you back privileges, but if you want, I can just continue forward for you.
Sure, that would be fine. So if you could advance it one more, and we'll finish up with wind. So wind turbines use blades to collect the wind's kinetic energy. Wind flows over the blades, creating lift, which causes the blades to turn. The blades are connected to a drive shaft that turns an electric generator to produce electricity. Similar to solar, large arrays of wind turbines are often referred to as wind farms. The one shown here is in Traverse, which is in Oklahoma. This is now the single largest wind farm in the US as of March of this year. Can you advance it? Sorry, folks, we seem to have some technical troubles here.
I'm sorry, Angela, is that too far?
I am only seeing the renewable energy slide. Is anybody else seeing something different?
I'm seeing emerging renewable energy technologies.
Okay.
So
Maybe my screen might be frozen.
What I think I should do, Angela, is I'm going to change you to the presenter, and then you can share your screen. You
Okay.
think that would work?
Sure.
So I'll stop showing my screen, make you the presenter. So now you should be available to change or to share your screen.
Can you see my whole screen or?
Yeah, I'm seeing your entire screen.
Okay, that's not what we want to do.
Yeah, now I'm seeing just the presentation, I believe. Or that actually may be my end.
Sorry, folks. Okay, is that working?
Yes, that is working.
Okay, sorry, everybody. Okay. So we're gonna blast through these because we already did that. And then on to emerging renewable technologies. So the first one that I have here is marine energy, which also includes tidal energy. The infographic that you're seeing here came from the Office of Energy Efficiency and Renewable Energy. The design you're seeing here is for something called PacWave. It's an energy department funded test facility for wage energy conversion technologies and will be the first of its kind in the United States. The
Hey,
site is
Angela, it looks like we are still seeing your notes on the screen, just so slightly.
okay. This is not what we wanted to have happen. Mike, we might have to have you present, sorry.
No, it's okay. I apologize. My cat ran across my keyboard, so I believe that's what caused this initial issue. So we are on slide 8 still. I will show my screen and go into presentation mode. Are
Okay,
you still unable to click through?
yes. So we'll just have
Okay.
you advance the slide. Okay, so you can go to the next one. Okay, so this is something that is being referred to as green hydrogen. NASA began using liquid hydrogen in the 1950s as rocket fuel, and NASA was also one of the first of them to introduce hydrogen fuel cells to power electrical systems on spacecrafts. The hydrogen fuel cells produce electricity by combining hydrogen and oxygen atoms. The hydrogen reacts with oxygen across the electrochemical cell, similar to that of a battery, producing electricity, water, and small amounts of heat. Hydrogen can be created through two sources. It's either electrolysis or steam reformation. During electrolysis, the current is run through the water inside an electrolyzer, splitting up the molecule and producing hydrogen gas. Reformation puts a hydrocarbon, such as natural gas, under intense heat and pressure, thus producing hydrogen gas along with byproducts. Hydrogen produced by both electrolysis and steam reformation can be carbon-free when using renewable or zero-emission feedstocks such as wind, as you see in the infographic. This came from the Fuel Cell Hydrogen Energy Association, the FCHEA. Go to the next slide. So despite all of the recent improvement in technology and efficiency, as of 2020, renewable sources of energy still only comprise about 12% of the US energy consumption. The top three renewable energy sources were biomass, wind, and hydroelectric at 39, 26, and 22% respectively. Next slide. However, not all sources of energy are used to produce electricity. This graphic from the EIA shows that energy sources are used for various purposes in our economy. In the case of petroleum, the vast majority, 68%, is used directly as fuel for transportation services. In 2020, renewable energy provided about 11.59 BTUs, equal to 12% of the total US energy consumption. The electric power sector accounted for only about 60% of total renewable energy consumption in 2020, and about 20% of the total US generation was from renewable energy sources. Although there's a wealth of information provided in this graphic, the main reason I'm showing it here is to distinguish how convoluted the energy sector is in the US economy. Some sources are used directly by end users, while others are converted into electricity or other products, then sold to consumers. Today, we are mostly going to focus on electricity, but I just wanted to acknowledge that the use cases for renewable energy economic impact analyses projects are across the entire spectrum. Another important thing to highlight from this is that it also takes energy to convert energy. If you look at the little black and gray box at the bottom, this is the electric power sector. Less than 40% of all energy BTUs in the US, by source in the US, are used to produce electricity. And of that, only 35% is actually used by consumers. Nearly 65% of electricity is lost in the production or transmission of electricity itself. So how have we here at IMPLAN made sense of all this? The short answer is that it wasn't easy. You can go to the next slide. Just jump to the next one right after that. So let's take a look at IMPLAN's energy industries. But before we focus on energy, let's talk briefly about industries in general. At IMPLAN, we define an industry as made up of firms with similar input patterns. They are a group of establishments or businesses engaged in the same or similar types of economic activity. For example, any company manufacturing personal vehicles, Honda, Ford, Chrysler, Tesla, would all be classified in the same industry in IMPLAN, Industry 340, automobile manufacturing. Each industry produces a good or service known as a commodity. In our manufacturing example, the commodity here is going to be automobiles. An industry can create more than one commodity, therefore a commodity may be produced by more than one industry. In our automobile example, not only does Industry 340 produce automobiles, but it also produces light passenger trucks. Next slide. There are 546 IMPLAN industries in the current aggregation scheme. They can be summarized into these 11 industry groupings. As some of you may have noticed, the IMPLAN industry groups are going to be similar to that 2-digit NAICS scheme with a few exceptions. And that is because IMPLAN's industry scheme is based largely on the BEA's input-output benchmark table. Every 5 years, the BEA updates their input-output accounts, which means that on those years, IMPLAN datasets also undergo important updates as well. The last update occurred in our 2018 dataset and will be used through our 2022 dataset. Annual IMPLAN datasets are typically released the following year that they occurred. So we just released our 2020 dataset in December of 2021. Next slide. There are 5 major components to an industry and IMPLAN. This is the Leontief production function or output equation on which IMPLAN's calculation of results are based. The LPF of an industry and IMPLAN determines how much each industry will allocate output to these 5 components. Most industries have employees or owners, and they pay them labor income. They also pay taxes and realize profits, which is that OPI, other property income. These 4 combine to give us the value-added portion. In addition to the value added, industries also spend money on intermediate inputs, all of the goods and services that they need to produce their own goods. Each industry in every region, whether it be county, state, or zip, has their own unique Leontief production function, or LPF. We use a plethora of sources to compile our industry data for each annual data set. To get our labor and employment data, we use the BLS's CEW data, which is the Census of Employment and Wages. We use the Census Bureau's county business patterns and the BEA's regional economic accounts. We also use the regional economic accounts to get the annual GDP, which of course labor income is a part of. Then we use the BEA's input-output benchmark table, the one that I just referenced, to get all of the industry inputs, to figure out what are all the goods and services that those industries need to produce their product, and also what products they produce, which is known as their byproducts. So each industry produces a primary product and byproducts. We also get some other information that's related to industries. We get the trade, so how much of those commodities are traded abroad, the margins that are applicable to all of our retail industries, and then the investment spending patterns, because not only do industries purchase goods to create their products, but they also invest in capital. So that is where we get that information from. So that leaves for us output. Output, unlike the other pieces of data, does not come from one source. This data we collect from a multitude of sources. So the retail and manufacturing industries, we collect those from the US Census Bureau. It's the annual retail trade survey and the annual survey of manufacturers. For most of the service sectors and actually the mining sector, we use the output series from the BEA. For farming, we use the NASS, which is the National Agricultural Statistics Service, and the ERS, which is the Economic Research Service. And for fishing, we use NOAA, which is the National Oceanic and Atmospheric Administration. And then last but not least, we use the EIA for all the electricity, oil and gas extraction, and petroleum refining, which is what we are talking about today. So now we have all the data components necessary to compile these energy industries in IMPLAN, right? Well, not quite. The main problem that we came across when creating our industry aggregation scheme was that the BEA's benchmark table, that IO table, that we use to compile all of our industry inputs or those intermediate inputs, only provided data for 1 out of the 405 industries for energy. It was the electric power generation, transmission, and distribution. As we mentioned in the beginning of the presentation, the US energy sector is very convoluted. So we decided that we need to split this one energy sector up into various industries that produce energy and those that provided transmission and distribution services. So how did we do all this? Well, first we gathered our data. Our data came from 3 main sources. As we already mentioned, total output or revenue came from the EIA. From them, we were also able to gather data on the megawatt per hour by energy source. A megawatt per hour is equal to 1,000 kilowatt hours. We also use data from the EIA that split total revenue into the generation versus transmission. So how much money went to the people that generated the electricity and how much went to those who transmitted it. We also used wage and salary employment and income data from the CEW series to distribute output into public versus private industries. And then last but not least, the IMPLAN group contracted with Skip Leitner of the Economic and Human Dimensions Resource Associates in 2014 and 19 to break out that one single aggregate industry into multiple industries. So he, with the help of him, we were able to produce 8 electrical power generation industries and 1 private electric power transmission and distribution industry. So all of those have separate production functions now. So just a quick look at what this, what the process was. So again, step 1, we gathered that megawatt per hour data by energy industry, and I just have this fictitious sample here below. We're just going to pretend that there were 4 types of energy sources in this area: hydroelectric, fossil fuel, nuclear, and solar. We took the total megawatt per hours, that's 70,000, and we divided the output in millions here, that 5.6, divided it by the 70,000 to calculate a dollar per megawatt hour. We applied that to each of the industry's megawatt hours. So we applied that value to 5,000, to 30,000, 20,000, 50,000 to get the output per individual industry. Then we had to attribute the industry revenue into generation versus distribution, because again, when we purchase energy, some of it stays with the distributors and some of it stays with or goes back to the people who produced it. And then last but not least, which is not shown on this table, we then took the industries and then split them into public versus private ownership. And again, we use that CEW employment compensation ratios to do so. Okay. Now let's take a look at electricity industries in IMPLAN. Again, as we said, we split out those industries due to a growing interest in more detail behind the generation and sale of electricity, for ways that can help businesses, analysts, and policymakers understand the change in both the technologies and the economics that underpin the consumption of electricity. So it was important for us to separate out the electricity producers and distributors because they operate very differently from one another. As you can imagine, the inputs that are required to produce electricity, the generation plants, are very different from those of the transmission and distribution companies. They are primarily responsible for those substation and then the transmission and distribution lines. IMPLAN has 13 energy industries. You can click once more, Michael. The first 10 industries are going to be the investor and independently owned industries. Again, and the bottom 3 are going to be those publicly owned utility companies. So those are industries 527, 530, and 533. Typically in IMPLAN, most industries produce their own primary product. However, in our case, there are only 3 energy commodities produced by all of these industries. And that is because the first industries listed here all produce the same commodity. These produce electricity, commodity 3039. Whereas the private industries, they produce a mixture of all 3. So not only do they transmit all of the transmission and distribution services, but they also generate some electricity and some natural gas distribution. So they're kind of a mix of all 3, which are very different from those private industries, which are strictly separated based on generation versus transmission. So it's a very important thing that I wanted to point out to everybody. So just looking at these individual commodities, again, we know that commodities are produced by more than one industry, and industry 30 or commodity 3039 is produced by multiple industries, 13 total. This table is actually found in your region details part of your screen. If you go into the commodity balance sheet and select industry, institution, production, you can see for any commodity who produces or sells it in your region. The totals that I have here are for the US. So just looking at this, you can see that energy is produced by 13 separate industries in the US. 60% of it comes from the fossil fuel plants, the Industry 40. 20% comes from that nuclear industry, which is Industry 41. And we see that a small percentage, 5.6, comes from local utility companies. Moving on to the next one is commodity 3047. So this is the transmission and distribution ones. So again, you would navigate to the same part of the screen in the region details to see who produces that. As we can see, it is primarily produced by that Industry 47. They have 88% of the market share, meaning they produce 88% of that total supply in the region. As we can see, government utilities also provide some of those services as well. And last but not least is the commodity 3048. This is the natural gas distribution. So as we can see, the majority of it is by Industry 48, but most power companies and also private utility companies do also provide natural gas in addition to electric. So again, small percentage comes from them, the majority coming from Industry 48 itself. But anytime you want to look at modeling these types of impacts, you want to make sure that you go into the region details to check out who's producing it in your region. These are totals for at the US level, but these vary drastically by region. So before you start your analysis, it always helps to check them out. And speaking of that, we're going to jump into some basic overall trends that we've saw in our data. We wanted to give you some updates to how the renewable energy sectors are going. Go to the next slide, Michael. Thank you. So here we have the country broken up into US Census regions. We have the West, Midwest, South, and Northeast. Some of the trends that we wanted to look at were related to output, but we did realize that output actually, a lot of these industries have been subsidized over the years, so we didn't want that to affect the trends that we were looking at. So instead of looking at output, we decided to actually focus in on employment instead. So looking at the employment trends across the country in our IMPLAN data, we have saw that solar employment overall grew by the most in terms of renewable energy sectors. We saw an employment increase of 328% over the last 20 years from 2001 to 2020. Again, as I said, everything varies by region. If we look at this, the West is just crushing it. In terms of renewable energy employment, they have the highest percentage of all of energy employment. 31% of all employees in the energy sector work in renewable energies in the West Coast. And they also have the highest percentage of each renewable energy. So all of the individual energy sources, all of them except for wind. That actually is surprisingly being led by the southern region. So they have the highest in 2020, but that region also saw the largest decline in hydroelectric industries over the 20 years. Hydroelectricity, again, I should mention overall, the industry lost 90% of employment across the US from 2001 to 2020. So if we were to exclude hydroelectricity from the renewable energy mix, we would see that the Midwest actually grew the fastest at the highest rate between 2001 and 2020. The Midwest does, although, have the lowest percentage of renewable energy employment in total. Only 12% of all jobs in energy are in renewable energy sectors there. And last but not least, the Northeast. They do not have a lot of renewable energy sources, but their hydroelectric power is actually the largest of the renewable energy sectors that they have, and that is at 4.8%. So if we move on to the next slide, we'll see that this does vary by state. Obviously, these regions have some high hitters and have some low hitters. The Western region was really high up there because of California. We see that California dominates in all of these categories except for wind. And again, wind has the highest in the state of Texas, which is why the South had the highest percentage of employment in wind. And just looking at, move on to the next slide. And if we just look at solar in particular, we can see that, again, solar was the big winner in terms of renewable energy. I just wanted to point this out that there are a lot of high-paying jobs in the solar industry. These are just the top 10 occupations in solar in the US. And we can see their total employment values. We have their wage and salary income, supplement to wages, and total employment compensation. We use that total employment compensation to derive an average average income per worker. So as you can see, a lot of these occupations are very high earning categories. Okay, so before we jump into estimating an actual use case, I want to talk a little generically about estimating economic impacts in the energy and renewable energy sectors. So as with all types of analysis, the first thing that you want to do is make sure that you're using the correct methodology. You should ask yourself some basic questions when you're setting up your analysis. Who do I hope to influence? What do I hope to find? Where will this be released? Why are we even studying it? And of course, when will this be needed? All of this information is going to help lead you to how you are going to set up these projects. Again, IMPLAN uses an input-output method. It's not always the most appropriate method to use when you're setting up some of these renewable energy projects. In some cases, a cost-benefit analysis might be sufficient. In other cases, you might want to consider doing some CGE modeling to make sure you're adding in all the other factors. So first step one is to ensure that IO is going to be the correct methodology to use. Second thing you want to do is outline all of the things that you hope to analyze with this. Then, of course, step three is to generate your hypothesis, state all of your objectives, and define your goals. Which, of course, leads into setting up your project in IMPLAN. A lot of people struggle with actually taking their project and converting it into IMPLAN, how to set this project up. And the biggest hurdle that most people find is how to select an impact type. As you know, we have several different impact types that you can use in IMPLAN. The biggest one that causes the most confusion, I think, is between that industry and commodity. Right? People are never sure when it is more appropriate to use a commodity versus an industry. Well, of course, if you know which industry is being affected, it is more appropriate to use that industry. However, if you're talking about commodities, as we're talking about electricity and other energy resources, it might be better to look at the commodity itself. Industries, of course, as we saw with the previous slides, can create more than one commodity. And of course, a commodity can be created by more than one industry. So just make sure that you're making the correct choice when you set those up. The second consideration that you should take when selecting an event type would be whether or not it's an appropriate to use an impact event or a contribution event. An impact analysis is going to help measure the economy-wide impacts of a change in final demand, whether it be positive or negative. In this analysis approach, any of the feedback effects to that primary industry are not going to be eliminated. Industry contribution analysis, on the other hand, is a method used to estimate the value of an industry or group of industries in a region at their current levels of production. While the focus of the analysis still is going to look at all those backward linkages, all the purchases that they made, the purpose of this analysis differs from the standard economic impact analysis. ICA is going to show you the relative extent and magnitude of the industry or event or policy itself in the study area. As always, we have those income events as well. So if you ever are looking at measuring a type of impact when it relates to household spending or savings, household income type will be the most appropriate one to use. We also have institution spending patterns in there. So if you're talking about a policy that is going to be enacted by a government or jurisdiction, using those institutional spending patterns might be more appropriate to use as well. As always, we do recommend setting up a net analysis whenever possible. A net analysis is going to report a holistic look of the effects resulting from a change in production or spending in the economy. It considers both the positive and the negative effects of a given scenario, which again are going to be more common in these projects that are related to renewable energy transitions. Input-output models are going to be linear in nature, but they are not general equilibrium models. Therefore, impact results from IO models are not going to be those net effects. So if you want to run one positive effect, or if you want to run one positive impact in one industry, the total results are not going to include any of those negative effects that might happen in another industry. So in that case, you'd want to model both of the effects separately to make sure you get the final net effects. And last but not least, you always want to consider those special considerations for industries. So for renewable energy, you want to make sure that you're talking about whether or not this project is related to the construction of new facilities or new equipment, or whether this is about the operations of those facilities and equipment. Again, some of the other projects that we see with renewable energies have to do with supply chain purchases. So is this company transitioning from using a source that is a fossil fuel or non-renewable source and they want to transition into a different source, or are they eliminating that purchase altogether? So again, looking at those supply chains analysis, which you can do in our industry spending patterns, our IIA events, and also the institution spending patterns. So to help you with setting up your renewable projects, we do have a couple support site examples that I wanted to highlight here. These are articles that you can find at our support site, which is support.implan.com. So the first one that we have here is going to be that electric vehicles on the move. This one specifically talks about automobile production, and it uses an industry spending pattern to modify some of the inputs. It also looks at the installation of charging stations and the construction of them. This article also does touch upon the subsidies and rebates that you often find with transitioning to an electric vehicle. So those can be run as household income events. The second article here is going to be on utility purchases and energy rebates. That one again focuses on the change in energy prices. So it looks at them on households, on producers, on industries, and on governments. Depending on which one you're looking at will determine which event type you want to use. Households, you want to set up those household income events. Producers, you might want to look at an industry output. So again, those are the people who are producing the products themselves, or a price change on industry. In that case, you want to look at modifying that industry spending pattern to remove, again, purchases from fossil fuels to a different renewable source. And then in governments, same thing. You're going to modify their spending pattern in the same type of way. And then we have our solar farm construction and operations article that looks at the construction and operations using industry events. We do talk about incorporating the JEDI models in that article as well. There is a link in that article to the JEDI models if you want to or are considering incorporating them into your analysis. And last but not least is one of our newer articles. This is a net analysis, switching to solar. So in this example, we were looking at power generation, switching from a fossil fuel to a solar industry. So we set up two events in this project. We had an industry event, a positive industry event in the one, and a negative industry event in the other to look at the net effects of those two. We also added in the environmental effects to show how switching over to different sources can improve the environmental impacts in your region. So just want to touch on a few things before we have Michael jump into an example. There are, of course, many other energy projects out there that you can model using IMPLAN. The first one is going to be those energy savings through on-site generation. So if households and industries are constantly looking to improve upon their energy savings by installing solar panels or switching to wind energy or something like that, those can be modeled directly in IMPLAN as well. Rebates, subsidies, investments, or incentives. We know that government has been involved in a lot of the transitions to the renewable energy sector. So again, you can use those institution spending patterns to model some of those impacts as well. Switching to electric vehicles, sometimes not only are you going to be switching production to electric vehicles, but you're also going to be looking at a reduction in fossil fuel consumption that goes along with that transition. So modeling both of those events, of course, can be done. Construction, power generation facilities and transmission companies also are making investments to increase capacity to meet the new renewable energy sources. So that's another big one that people are interested in modeling in IMPLAN. And then just the utility company's commitment to purchasing from renewable energy sources. So that is kind of similar to that switching to solar example that I mentioned in the previous slide. But you can, of course, play with that in terms of other renewable sources. And last but not least is going to be that increased production of renewable energy projects or products. So this is the example that Michael's going to go into next. So I'm going to pass it off to him and let him go through that.
Thank you so much, Angela. So now, like Angela said, we're going to go ahead and jump into a use case example. According to the Office of Energy Efficiency and Renewable Energy, to achieve a clean energy future that is made in the United States of America, we must strengthen and secure the following domestic manufacturing supply chains. Again, for those supply chains, we're going to focus on three main areas: rare earth magnets, metal catalysts, and semiconductors. If you don't know, semiconductors are an integral part of the clean energy economy. They power electric vehicles, energy efficient industrial and building applications, as well as electricity generation. Efficiency is also key, as computation intensive applications like cryptocurrencies are utilizing immense amounts of energy to do so. Also, in the last 25 years, the United States, who was once dominant in the manufacturing of semiconductors, lost roughly 16 percentage points in our share of global semiconductor manufacturing. In January, the state of Ohio, however, announced that Intel chose Greater Columbus, Ohio area to build one of the most advanced semiconductor manufacturing facilities in the whole world. This $20 billion investment will be fully operational by 2025 and will add 3,000 jobs to the local economy with an average of $135,000 in labor income. In IMPLAN, we could model the operations of this new manufacturing facility through Industry 307, semiconductor and related device manufacturing. For the state of Ohio in 2019, there were roughly 2,226 employees in Industry 307 that all had an average employee compensation of $110,665, and the industry supported a total output of roughly $1.2 billion. So now let's take a look at how our new facility could potentially change the state of Industry 307 in Ohio as it currently stands. So to analyze this in IMPLAN, we could use our brand new event type, the Industry Impact Analysis Detailed Event. And with this event type, we could input our total employment equal to our wage and salary employment, which would be 3,000. We could also input our total employee compensation for the state or for all of these workers. So remember, these workers make roughly $135,000 of employee compensation on average, which when multiplied by our employment value of 3,000 would give us a total employee compensation value of $405 million. Again, this is going to be all the labor income earned by those wage and salary workers. So this is also going to be equal to our total labor income. So we could run this event through a group with our region specified as the state of Ohio and our dollar year in 2025, because that is when this manufacturing facility will be fully operational. So when we run that, we'd get the following results that I went ahead and pulled for this analysis in 2025 dollars. We can see our direct employment value in the top left of 3,000, which we inputted, as well as our direct labor income that we specified as $405 million. These two values allowed IMPLAN to estimate the direct output that would be supported by this new manufacturing facility of around $1.961 billion, as well as $530 million of value added. In total, this new facility would support about $1.15 billion of labor income to go along with just over 13,640 employees. And our total output from this analysis would also be just over $4 billion. So digging a little bit deeper into our results within the IMPLAN application itself, we can see which industries would grow the most given our new manufacturing production within our output tab in the results. So looking first at this industries by estimated growth percentage table, we can see that our top 5 industry by estimated growth percentage are going to be, of course, the top industry would be semiconductor and related device manufacturing, which grew over 164%. Next, we would have industrial gas manufacturing, which grew at about 2.32%. Third would be concrete block and brick manufacturing, which grew 1.27%. And management of companies and enterprises, which grew or just disappeared. Apologies for that. Go ahead and reload all of our results. I guess we've got timed out. So yeah, our 4th largest industry here by growth percentage is going to be that management of companies and enterprises, which grew about 1.16%. And then our 5th largest industry by estimated growth percentage would be our wholesale household appliances and electrical and electronic goods, which grew just under 1%. We could also utilize the occupation impacts table within our results to see how this new Industry 307 production changes the occupational outlook in the state of Ohio. So sorting the occupations table by wage and salary employment, which it does not want me to do for some reason. So yeah, we're again viewing this in 2025 dollars. We'll sort this table by wage and salary employment. We can see about 670, just under 670 material moving workers are going to be supported by this new facility, with 661 or so computer occupations as well. And if we go ahead and sort this table by employee compensation descending, we can see that those computer occupations, occupation code 15-1200, are going to support a high level of wages and salaries as well, but that the top EC occupation here would be engineers, which of course that makes sense. And if we head over to our environmental results and reload the page, we will get more of a holistic view because we have to be reminded here that all of these increases in production are great, but they also are going to lead to an increase in our environmental footprint as well. So this is kind of more that holistic view that Angela was talking about, reporting the good also with the not so great. So looking at our region's environmental summary here from our dropdown, and looking at our industry environmental summary, let's pay attention first to our greenhouse gases. We can see here that across all industries, that this new manufacturing facility that we're modeling would contribute just under 646 million kilograms of greenhouse gas emissions, so not insignificant by any stretch. And that would be a significant or the predominant portion of our total environmental impact of just under 830 million units. So again, increase in production, great, but it does come at a cost. So now coming back to thinking about our economic indicators, this first row here in this table is going to be those 2019 Ohio State data points deflated to the 2025 dollar year. So all else equal, this would be how that industry would look in the state of Ohio in 2025 without our new industry production. So to get to these values, I utilized the deflator data in IMPLAN's data library. So we'll come back here. And unfortunately, this has also been lost. So in data library, you can reference this pre-built dashboard here, our deflators data. And then you can see the deflators for any industry from any data year to any dollar year of IMPLAN data. So we're going to want to see from 2019 to 2025. And we want to focus on our industry 307 so we can get that deflationary factor. So as you can see, our deflator is going to be less than 1, which means kind of along with that trend that we discussed, that this industry is steadily declining over time. So I took this value here again and applied it to that underlying Ohio State data for 2019 to help paint a picture of what the semiconductor manufacturing industry would look like in this state if everything remained as it was. Row 2 here is going to be our 2025 operations of the new facilities, or the direct effect from our results. Again, so that's going to be the impact results from our IIA modeling our new Industry 307 output. Just with a quick glance, you can see that this output value is nearly twice that of how Industry 307 would look without this new manufacturing plant. And then lastly, our row here is how Industry 307 would hypothetically look in the state of Ohio in 2025, given this increase in operations. We can see that these new operations more than double wage and salary employment, employee compensation value added, as well as output. And then lastly, here we have some percentage changes from what the state of Ohio would have had in Industry 307 all else equal versus with that increase in production that we're trying to model. So across the bottom here, we can see that those new industry totals that we are estimating saw wage and salary employment grow by about 135%, and employee compensation value added and output all grew by roughly 171% after we have rounded. So definitely some significant changes brought on by this new semiconductor manufacturing plant. And with that, I'm going to go ahead and pass the buck back off to Angela to finish off the presentation.
All right, thank you, Michael. So again, apologies, we are running out of time here. We have approximately 2 minutes left. So if you do have any questions, quick hurry up and throw them in the question box, and we will make sure to respond to you personally. We'll send out an email to get you a response. We, of course, here at IMPLAN are always looking for topic ideas. So if you have anything that you would like to hear us present on, please let us know. We do these presentations once a month, so we want to make sure that any of our future sessions cover topics that are pertinent to you. So you can email us at support@implan.com to submit your ideas. If you are new to IMPLAN and would like to get some resources on this, you can go ahead and also go to our website at implan.com/demo to set up a demonstration with one of our sales teams. You can use this demonstration to explore the type of data that we have in IMPLAN and then get some specific information on how you could set up a project in there. And if you are a current user, then you should be familiar with one of our 4 CSMs. We have Rada, Brian, Meg, and Colton all here to answer any questions that you may have. You can email them again at support.implan.com. Or if you would like to pose any questions to us, the Education Services team monitors our community forum. So there you can pose a question related to your project or a topic and have any one of us from the team respond, or anybody else in the community can respond as well. So all of our IMPLAN Link and Learn series are going to be found on our support site as well. If you go to the support site and go down to the lower left-hand box under IMPLAN products, you will see the webinar will be shown there. The recording of it will be shown there. So with that, I want to thank everybody for joining us today. It has been an absolute pleasure, and we are finishing right on time. So thank you again, and please join us next month.
Thank you, everybody.